Alright guys, welcome back to Dr. Perkins, the Medical Master. So today I'm going to help you learn about neurons. So what I have behind me are some pictures of neurons. And so what are neurons? Well, neurons are the thinking cell of the brain, the nervous system. So when you hurt yourself, oh man, I hit my finger, right? Why are you able to feel that pain? Because you have a neuron in your finger that sends the message up to your brain, ow, I hurt myself, right? Likewise, when I say arm move, right, my arm moves because I have a neuron in my brain that sends the message down to my arms, time to move. The way I'm able to see, hear, smell, taste, think about things. All this is happening because the nervous system and the backbone of the nervous system, the thinking cell of the nervous system, is the neuron. So here are these neurons right here, and this is the most common neuron in the nervous system, multiple neurons. So we're just going to start with the basics and work our way down. So right here, you see this thing kind of looks like it needs a haircut. These bushy things, these are going to be the dendrites. These are kind of like the ears of the neuron or the eyes of the neuron, right? It's taking information about what's going on around this neuron to the soma, the cell body. And so this thing right here, this is an axon. All this area right here is the axon. And so this part where you go from the soma, the cell body, to the axon, this is called the axon hillock. And so this part of the axon says whether or not it's going to fire. And so when it fires, the electricity moves all the way down to the end of the axons right here. Now, some axons are myelinated. Notice these blue little boxes right here. And that's going to speed up how quickly the electricity can move down the end of that axon. Over here, neuron number 2, it's not myelinated on its axon, right? So it can be either myelinated or unmyelinated axons. Anyways, next thing we have is you see neuron number 1 and neuron number 2 are touching. And so I blew this little touching part up because they're not actually touching. There's a small gap here, right? Here's the axon of neuron 1, and here's the dendrite of neuron 2. And that small gap is called a synapse right there. All right. And so what happens is in order for neuron 1 to be able to talk with neuron 2, neuron 1 has to release a chemical called a neurotransmitter. And so it's just going to move the message from neuron 1 to neuron 2, right? Now, neuron 1, they call this a presynaptic neuron. Why? Because I'm before the synapse. Neuron number 2, so is a postsynaptic neuron. All right. Why? Because I'm after the synapse. Now, this is the 1,000-yard view of what's going on, right? So we have neuron number 1 is talking to neuron number 2. And so what happens is with neuron number 2 is I can tell neuron number 2 to either fire or don't fire. Well, neuron number 1 isn't the only show in town, right? I might have other neurons firing on neuron number 2 telling it to either fire or don't fire. And as I said, if I have more signals telling me to fire than don't fire, then neuron number 2 is going to fire. Once again, what's happening is all this information is coming down here, either fire or don't fire, and depending on how this axon hillock is feeling, whether it's getting more messages and stronger messages to fire, then it will fire. The default is not to fire. So you have to make me really excited, right? Not only do you have to outweigh the messages not to fire, but you actually have to outweigh my own not wanting to fire, my own desire not to fire. So how does this work? On a gross level, it works something like this. So I've added a couple of axons from different other neurons, right? We can't see them because they're way far in the back. So if this axon fires right here, right, we're opening up sodium channels, and so it's going to be a very strong message, fire, right? But you notice right here, the message is going to start getting weaker, weaker, weaker as it travels further away, right? If I'm right up here, it's going to sound very loud versus, right? When I fire here, the message is a lot louder, but as I move further away, the message is getting softer. right? And so by the time the message gets over here, it's nowhere near as loud as what it was right there. That's a graded potential, right? The message is getting softer the further away I get from where the message was received at, right? A message over here is going to be even weaker. Why? Because I'm having to travel really far distance. And so it's going to get very, very weak. All right. We'll just say, for the sake of argument, this neuron is saying, fire, don't fire. So it's sending a message. And as I said, right here, it's pretty strong. But as I move further and further away, it's getting weaker, weaker, weaker. And so you see these two messages are kind of fighting each other because this neuron is closer than this one. By the time the message reaches here, right, its message to fire is going to be stronger than this one's message not to fire. The other thing is how often are you sending these messages, right? You might have, let's say, a loved one that thinks it's really important for you to go to college. But if they've only told you once in your life, go to college, it's not going to have as big of an impact. Another loved one that's fairly close is telling you every single day, you need to go to college, you need to go to college, you need to go to college. The other thing, how close is this person to you? Some random person on the street might tell you every single day that you're crazy to go to school or whatever, you need to be a plumber, but because you don't really know them, they're not going to have much of an impact, even though it's every single day. But somebody that's extremely close, the second they tell you something, is going to have a huge response. So you see the axon of a different neuron is right next to this axon hillock of neuron number one. It's going to have a huge impact on whether or not this fires. Number one is not going to fire. All right, so why is this?
You'll have to watch my next video.